This laptop is being fixed. Okay, so 1, 2, 3, 4. Are we agreeing? Then we look at what? At 5. Huh? So we are supposed to add 1 here. But if you add 1, it becomes what? 10. Huh? So it's a 0 carry 1. Then we add 1 there. This becomes 6. Huh? Can you see that? So it means our answer is almost similar, 0,0060, huh? Because they have to be 4 digits after the decimal place. Clear? Though in terms of value, it's the same with this. Huh? Now to 5 decimal places. 1, 2, 3, 4, 5. Can you see that? Then you add where? 1 there. Huh? So what's the answer? 0.005. What did I say? 1, 2, 3, 4, 5. Oh, we are simply adding 6 here. So 9, 6. Huh? Are we agreeing?
Yes, sir.
To 6 decimal places. 1, 2, 3, 4, 5, 6. 1, 2, sorry, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so this becomes a 7 here. Can you see that? One, two, three, 4, 5, 6. Okay, this becomes a 7. 5, 7. Are we agreeing?
Yes, sir.
Now, let's twist this now. What you need to remember is the significant figures. The decimal places most of you remember, but people fail on the significant figures. Now look at this. So if I say to 1 significant figure, remember what did I say about significant figure? I said you start counting from what? From the non-zero. This is not. This is a 0. This is a 0. This is a 0. So where do I start? There. Let me see that. And this I add to that. So it's simply 0,006. Makes sense? Two significant figures. Oh, I start counting from 9 to 0. So 1, 2. So almost the same thing that we did. This becomes a 0. This becomes a 6. So 0.0060. Are we together there? You see the difference?
Yes, sir.
Yes, between, so I'll give you an exercise. Significant figures and decimal places. Okay, then moving on. So that's what you need to know for your syllabus. Can't afford to lose these free marks here. Okay. Now, we apply this also to what we said is when we are rounding. Huh? When we are rounding, or when we're doing approximations in maths. When you're doing approximations, we use this. For example, I can say I'm given length of a cloth. Let's say length of a cloth is 10 centimeters. Then I'm told that this is to the nearest 5 millimeters. You can write that down. To the nearest 5 millimeters. Huh? We covered this last time, but I'm just revising to the nearest 5. I may want to apply what you've been. Length of a cloth is 10. So you can be asked to find the possible range. Find the possible range. So by possible range, because I have done an estimation of a cloth to the nearest, it means I have the highest and the lowest. Does that make sense? So if I say find the possible, it means the lower boundary. It means lower bound less than, clear, less than or equal to my measurement, x less than my upper boundary. I hope you are following me. Upper boundary, clear. Lower boundary less than or equal to x is the measurement, less than or whatever you are measuring, whatever is in question, less than that. Clear now?
Yes, sir.
Now, so to find the lower bound or the upper bound, we find what is known as degree of accuracy.
Okay.
Degree of accuracy is what we find first. By degree of accuracy, simply look at this to the nearest 5 millimeters. But my measurement here is in what? Is in centimeters. So my first question is, what is 5 centimeters to millimeters? So what is 5 millimeters to centimeters?
0.5.
Yes. So this is 0.5 divided by 10. That's correct. 0.5 centimeters. So I'm saying degree of accuracy here is the 0.5 centimeters divided by 2. We always divide this by 2. And from your calculator, you'd get 0.25 centimeters. So your lower bound is always the measurement minus the degree of accuracy.
Yeah.
Upper bound you add. So it means from what you have just said here, our lower bound is simply equal to 10 centimeters minus 0.25. What do you get?
9.75.
Yeah. And upper bound, you add and you get 10.7, 10.25. Which means now, to answer the question, it simply means now we now have everything. So in terms of writing the answer, you're saying 9.75 centimeters less than or equal to x, x less than 10.25 centimeters. Is that clear?
Yes, sir.
Now, I can be given things like length of a rectangle, which you know, and things like that. Let's say I've got a rectangle here. And let's say these are approximations. And let's say this is 900 meters. And let's say, maybe we can draw something like that. Let's say this is 450 meters. So let's say L length, which is 900 meters, to the nearest 50 meters. Clear?
Yes, sir.
Then W, I want to show you something here. W, let's say, which is 450 meters to the nearest 10 meters. So we can be asked, for example, to calculate the lower bound area and the upper bound area. And if we were to calculate the lower bound area, we need to find the lower bound for this and the lower bound for that. Clear?
Yes, sir.
Now with the nearest, it means degree of accuracy for length there is simply equal to 50 meters divided by 2. And that gives you 25 what? Meters. So in term, it means the length here is equal to 900 minus 25. Clear? Which gives us 875 meters. Then for width, it's to the nearest what here? 10. So width is equal to 10 meters divided by 2, which gives you 5 what? 5 meters. Huh? So then you subtract 450 minus 5 meters, and you get 445 meters. Then you know that area is length times width. Huh? You're multiplying the lower bounds as they are. Clear? Make sense?
Yes, sir.
So that in itself is easier. Where it becomes tricky is where I divide something. For example, I know that speed is equal to distance over time. Huh? So for example, if I'm told that the distance D is equal to 700 kilometers to nearest 100 kilometers, then the time is equal to 4.55 hours to nearest 2 decimal places. I hope you are writing this. Huh? Nearest 2 decimal places. Now, so if I want to get here, so if I want to find the maximum possible, maximum distance, sorry, maximum speed, there's something that I need to mention here. What do you think? Do you think you divide by the upper bound distance divided by the upper bound time?
No.
Is divided by the lower bound time. Huh? That's why it will be divided by the greater value divided by the lower bound time. Clear now?
Yes,
So
sir.
upper bound distance. So distance here, for distance degree of accuracy is what? To the nearest 100. So I'm saying 100 kilometers divided by 2, we get 50
50.
kilometers. Then the upper bound here, we're going to say the distance is 700 plus 50, which gives us 750 kilometers. Clear? Then a lower bound for timer. Now, what's to the nearest 2 decimal places? Huh? That's why you have to be careful. 2 decimal places, it means 0,01. Can you see that? Divided by 2. If I say 1 decimal place, it means 0,1 divided by 2. Huh? 0,01 divided by 2, what do you get?
0.005.
0.005, like this, correct? Huh? 0.0, so you subtract from this now because you want lower bound. So 5.55 minus 0.005, what do you get? You get 4.0.
4.545.
4.545.
4.545.
Then you plug in here. We said 750 divided by 4.545. Are we together then?
Yes, sir. 165.
Yes, get 165 kilometers per hour. Are we together?
Yes, sir.
Kilometers per hour. Which means then I'll give you a small exercise to work on what we have just said for okay, so let me see. So I'll send you a small worksheet just for you to practice.
Yes, sir.
on the upper bounds, and on the good thing is it's also there on extended, though of
Yes,
course
sir.
it'll be more challenging. Okay, so we'll give you, since you're the only one, we'll give you a break there. Then we see you at half 10 for
Okay,
an
sir.
hour. I hope you all have got your graph books.
Yes, sir.
Okay,
Thank you, sir.
you're welcome.